Chapter 2.1 also includes a lesson on finding the derivative function or sketching a derivative function from the original function. So I want to go over that with you with a number of different examples here, and I'm sure by the time we're finished you'll have this all figured out. For some people it's obvious, for some people it's painful. Let's make it obvious for you. Okay, so remember that when you're sketching a derivative function, you're actually sketching the slope function. So what we're trying to do is figure out what is the slope, or are the slopes, to this function as we move a tangent line around it. So in this first example, you can see the equation is a line. It has one slope, and in this case the slope might be 2. So the derivative function would be the line y equals 2, something like that. Okay, we're approximating it, so don't say, oh, I think it's more like 1. So it's a line above. So what I've done is underneath here I've sketched another axis so we can draw it right underneath. And in function 2 here, if I asked you, what is the slope of this line? You'd say, oh, the slope, rise over run, this is a slope of 0. So that means the derivative function would be f prime x equals 0. So it's right on top of the x-axis. So we're moving our way here. What's this one going to be? Obviously negative slope. So if it has negative slope for the entire function, I can only draw one tangent line to it, and that is the line, and that would be a slope of negative something. So we'll draw that one down here. As we get into the curves, things get more interesting. If we look at this curve here, it has, well, this is like a sine or a cosine function, right? So the reason there's sketches all over this already is because I did this whole lesson and then we had a little problem with storage on my iPhone. So it's a bit messy, but we'll get to it here. Okay, so I want to know on this function, where is the slope 0? It's the first thing you want to identify. So I drew some little lines here. Where is the slope? The tangent slopes, right? Because remember, a derivative is a tangent line or a slope function. So in these 3 places, we have a slope of 0. So I'm going to dot zeros everywhere I have 0 slope. I'm going to now go between this point and this point. Now watch what happens to my ruler. Don't look at this curve. Think of what's happening to the slopes as I move around this curve. So here the slope is 0 and it starts increasing. See how my protractor is pointing up? So positive slope, positive. Think of these as tangent lines. I'm drawing a whole bunch of tangent lines to this. And when I get about here, I start coming down again, right? If I was drawing tangents. So at this point here, that's the most positive or the steepest point on this curve between here and here, right? That's the steepest point of a tangent line, and then it comes back to 0. So if we approximate some values, so let's just say, I'm going to go like from 0 to 3. So let's say this is 0, this is 1, this is 2, this is 3, this is 2, this is 1, this is 0. So I went from 0 to 3 and back to 0. So at this steepest point, that's going to be my highest point. 0, 1, 2, 3, 2, 1, 0. Do you understand? I hope so. I can't hear you. This point here is what we call an inflection point. It's the point at which you see my tangent lines are under the curve, and then now they're going to be over the curve, or the place where your tangent lines start to change direction again. Or not change direction, but actually, yeah, they go up to the point, a maximum, and then they start coming back down. So on the other side of this curve, you can see I'm going from here, 0 slope to 0 slope. And as I go down, now these are all negative slopes. So this might be the most negative right here. So let's say that's -3, -2, -1, and 0. So this is going to be the lowest point. And I'm going to go like that. Now what happens at the end of these is still important. So I had 0 slope, and then it was positive slope, so like 1, 2. So I'm going to just bring this up a little bit like this one. And on this side it was -2, -1, 0, so I'm coming up to the 0. Okay, so that's all you have to do. Now let's watch this one. So first of all, find your zero slopes. Zero slope. One here, one here. Between this zero and this zero, there's going to be a point where my tangent lines, and remember, it's like me doing this, right? What's the slope of that line? What's the slope of that line? What's the slope of this tangent point? And you're going all the way around. So this is like 0, 1, 2, 3, 4, 3, 2, 1, 0. So right about here, this inflection point, that was my highest point. I'm going to put it here. So it's going like this. Went up, 4, 3, 2, 1, 0. So now I'm back to here. What's happening on this point? On this side, they're negative slopes. So negative 1, 2, 3, 2, 1, 0. So again, I have another little inflection point right about here. It's also considered the point where the graph goes from being concave down to being concave up. So if I had a function like this, it would be concave up to about here. See, the concave up and concave down on this side. So this is the most negative. I'm so sorry. I've lost my voice. So about here and come back up to 0. And on this side, I have -1, -2, -3. So it's most negative and back to 0. You have to get to 0 somehow. So I'm going from almost a 0 slope here, and then it's going negative, and then it's coming back up like that. So there's my fancy little curve. Okay, look at number F6 here. So what it was actually a matching game for them to find the ones that matched, and it's not necessary that you see this. More important that you see how we draw the derivatives. Okay, so this one, where's their 0 slope? Right here. Put your 0 on your axis for your derivative function. This is negative slope. So it's very steep. So like -6, 5, 4, 3, 2, 1, 0. And then it goes negative gain. -1, 2, 3, 4, 5, 6. So -6, 5, 4, 3, 2, 1, 0. -1, 2, 3, 4, 5, 6. Okay. This one looks like a parabola. Where's the slope 0? Right here. I put that on my line. What can we say about the slopes here? Well, they're very positive here. If I drew a tangent line, remember tangent lines, and it goes towards 0. And you know what the derivative of x squared was. We just did it in the previous lesson. Derivative of x squared was 2x. So it is going to be linear, but this time we're going from positive to 0 to negative slopes. So it's going to be going down this way. Positive slopes, 0, negative slopes. Derivative of a negative parabola is a negative sloped line. This one is quite similar to this one that we did over there, only we have our zeros in slightly different places. So we've put on all our zeros. This was negative slope to 0, negative slope to 0. Between here and here, I have to go up. So these are all positive slopes. So 0, 1, 2, 3, 2, 1, 0. Maximum at the point of inflection where it's changing direction. And here, same thing between here and here with these S-shaped curves. It was concave down, and then it becomes concave up. So the steepest slope is going to be right there as we approach back to 0. So 0, -1, -2, -3, -2, -1, 0. So we go under, back up, and then from here on, it's positive slope. Okay, I think you're getting the idea, right? Find the 0 slopes. I sketch them on. Where is there a change in direction for this one? That would be right about here. That's going to be my highest point. So I have to go up to it and back down. And here the slopes are all positive. So I went from, so I had negative slope. Whoops, I went the wrong way, didn't I? That was most negative. Getting too cocky here. Don't you do that. Okay, so these were negative slopes, most negative down here. So I'm down here, I come up, and then from here on, it's positive slope. And this is positive slope down to 0. So look, this looks like a quadratic, doesn't it? And does this not look like a cubic function? So remember, when we take the derivative, we lose one power. So if we have a cubic function, it's going to go to a quadratic function, and that makes perfect sense. This one is a parabola, so it should be a line, right? So 0 slope, positive slope, negative slope. So positive slope, we're up here. So this is like 3, 2, 1, 0. 3, 2, 1, 0. And here we're negative, so we're underneath. There we go. And the last two, might as well do them all. 0 slope, 0 slope. These are almost 0 slopes, aren't they? As I go around here, the slopes, best with a ruler, watch. So I go 1, 2, 3, 2, 1, 0. 1, 2, 3, 2, 1, 0. 3 was about here. 1, 2, 3, 2, 1, 0. And on this side, I have like 0, negative 1, 2, 3, negative 3, 2, 1, 0. So I'm going down this time and back up again. And last but not least, F12, find all your 0 slopes. 0 slope, 0 slope, 0 slope. Negative slope, negative. See my tangent line? And it's going to come around to 0. So I'm coming negative to 0. This one, at some point, there's going to be a change in direction. You see how it's kind of concave up on this side? Concave up past the cup, right? And concave down. Why the frown? So you can see this is going to be my inflection point. So that's where it's going to be most positive, and back to 0. And this one, now it's concave down to about here. And then can you see, like, there's a cup here, right? Here's my cup, here's my frown. So inflection point here, it's all negative slope tangents through here. So this is the most negative one. It's going to come down and back up to 0. And from here on, it's positive slope. So we just continue the line up. And there you go. That's your lesson on sketching derivative functions. I hope you find that helpful. And you have great success on your unit test, Chapter 2.